Welcome to Burn the Map. Today we're speaking with Dr. Craig Kaplan, one of the smarter, funner conversations I've had the luxury of participating in. Dr. Kaplan has worked in AI way before it was cool, as you will hear, one of the founders of superintelligence.com, focusing on the P-Doom algorithm and basically how to use the tools and workers that AI represents and turn them into a force of good for taking and enabling the human race to survive and thrive. Not just use these for nifty little widgets and things like that. Fascinating man, absolutely brilliant, as you'll be able to hear. And please take a good listen. If you like what you hear, please go ahead, like, subscribe, comment. If you have any questions, suggestions, or anything else for the show, hit us up and enjoy the episode. Would you mind telling me just a little bit about kind of how you came about working on and developing in the kind of the super intelligence space and company?
Sure. So first of all, Dan, great to be with you on this podcast. I appreciate the time and what you're doing. Super intelligence. So I've been working in the field of AI since the 1980s. So a lot longer than most of the folks. Way before it was cool. In fact, before it was mostly known by most people, I would say.
Well done, sir.
And I was very fortunate that I was introduced to the topic by Herbert Simon, who was my mentor and advisor and collaborator. We published research together. And he was a Nobel Prize winner, Turing Award winner, but also one of 11 scientists that sort of named the field in 1956, which was before I was born. I think I met him, I was 21 and he was 68 or something like that. And way back then, to just give you a sense of sort of the, where we've been, where we're going, and kind of where we are, if you mark 1956 as the birth of the field when it was named, way back then they had creative AI. So it was these 11 scientists got together at Dartmouth, and most of them were arguing about what do we name the field, and Herb and his colleague Alan Newell and Cliff Shaw, who was doing the programming, actually presented a working AI system called the Logic Theorist. And this AI program actually, it was designed to do mathematical proofs and sort of come up with the same proofs that were in a very famous book called Principia Mathematica. But it actually came up with a new proof that was not in the book. So they were very excited by this, and they didn't have email in those days. Yeah, so they mailed the proof off to the authors, which were Bertrand Russell and I think Alfred Northhead. And they mailed back and said, wow, this is a great proof. We wish we had thought of it. And so back in 1956, in some sense, you had AI being creative, coming up with something that was high quality, novel, and useful. So that was the beginning of the field. And then in the 1980s, which is when I arrived on the scene, it was a great time because that was the beginning of machine learning, really. It had been around a little bit before that, but machine learning, neural networks, pretty much everything that modern AI is based on that most of us think of when we think of large language models and Claude and GPT and Gemini and so forth. All of this is based on algorithms that were invented in the 1980s. And Jeff Hinton, who many people know, sort of known as the godfather of AI, I was in a research group with his collaborators, and we were reviewing preprints of that seminal paper, the backpropagation paper, back in the early 80s. So there was already this existing approach to AI, rule-based, where you programmed all the knowledge into the AI. It was expert systems is what they were known as. You would interview a human and then try to write rules to duplicate what the human was doing. That was the dominant paradigm from 1956 all the way to the early 80s. And then there was this brand new approach that Jeff Hinton and his colleagues were doing, which was, hey, maybe we don't need to program the rules in. Maybe the AIs can learn them themselves if we throw enough data at it and enough computational power. And there were these, table pounding arguments. I remember at Carnegie Mellon at the time, people got very heated about the whole thing, which is the right way.
That's a good sign.
It's always a good sign. Very passionate feelings on both sides. And at the time, it was very uncertain because computing power was not very high. So amazingly, Carnegie Mellon had self-driving cars in 1985. And I saw them. I used to go running in Shenley Park, which was right across from where the building was that I was working in. But they went about 2 inches an hour. It was a van that was hollowed out and it was loaded with as many PCs as you could stack. And it had video cameras and no driver. And it would move slowly. And then if it saw a leaf on the path, it would just sit there for an hour and say, what is that? Is that a leaf? Is that a person? And then say, okay, it's a leaf. I can move another inch forward. So that was solely because of the slow speed of processors, 286 processors, the early PC processors. And I ran the math once. If you did nothing else, kept exactly the same algorithms we had in the 1980s, but simply put in today's regular old processors that you and I have on our phones, our Apple iPhone or whatever, that van could go 186 miles an hour. So nothing except pure speed up in computing power was sort of responsible for a lot of these algorithms that didn't quite work very well or effectively in the 80s. All of a sudden, when you got to 2012, certainly, and even the early 2000s, all of a sudden they started working. And that's why we had the ChatGPT moment in 2022. Processing power had finally come to the point where these neural network algorithms became practical. So that's kind of a quick overview of sort of the beginning of the field, the 80s with machine learning, then the speed up that got us to ChatGPT. And then we get to sort of the question you asked, what is superintelligence and where are we going from here? So superintelligence can be defined as a general superintelligence. So let me go back a step. AGI, or artificial general intelligence, is usually defined as AI that can do any cognitive task about as well as the average human. That's kind of a more or less consensus definition. People have different flavors of that. And then superintelligence is, instead of performing the task as well as the average human, do it better than any human on the planet, right? So in some sense, we already have superintelligence in narrow areas like chess or protein folding, because you have AI that can beat the world champion in chess. I mean, there's no way that a human can ever beat an AI in chess ever again. That ship has sailed, but it's limited to a very narrow field. Superintelligence, when people talk about that artificial superintelligence, they're usually referring to an AI that can outperform the very best humans in any field. And in my view, that is definitely coming. And we can talk about sort of the great opportunities and the existential risks that comes with, and some of the approaches to try to make it safer, which is really what I'm focused on these days.
Awesome. Oh, so I absolutely would love to go a little bit into that direction, because I mean, I keep wanting to say the word like swarm intelligence, but crowd intelligence, I think, is a really smart way to think about it. A really kind of clever methodology. We talk about that AGI, that super intelligence, but largely you always think about it as, yes, it potentially borrows access to computing power coming from other nodes, but largely everyone thinks about it as like the Skynet premise, where there's one master quantum computer or something like that, and it ends up, it's so good in and of itself, it doesn't even need the rest of the other computers from then on. But the node and kind of the hive mind premise, when you talk about those kind of community based, crowd based super intelligence, are they basically borrowing? It's one of those where I could go, wait, is it the processing power? Is it the consumption of context? Or is it all of the above that's kind of doing it? Like, what's kind of the rule of communication logic that makes them work?
So here's a very interesting point where, in some ways, from what you've told me of your background in crowdfunding and interest in collective intelligence, you're kind of, I think, ahead of your time, even though there have been crowdsourcing projects and crowdfunding projects. And I myself built a financial services company and ran it for 14 years that did essentially crowdsourcing wisdom from retail investors. And we beat the best guys on Wall Street doing that. So it's possible to build those systems. And yet, the dominant paradigm right now of trying to reach superintelligence is more like the Skynet monolithic approach. So if you think about sort of GPT, you have GPT-3, 3.5, 4, 5, and so forth. And with each generation, the difference between the generations, they're basically using the scaling laws. They are throwing more data at it and more NVIDIA GPUs, more computational power, and allowing it to learn whatever it learns.
Yeah.
But it's one kind of model that's doing that. And that's one approach. And if you want super intelligence, it is possible. It's likely possible anyway. No one's built it, so we don't know for sure. But it's very likely that it's possible to just keep throwing more and more data and more computational power. And eventually, maybe it will be GPT-10 or something, will be so good that it's smarter than all of us at pretty much any task. And that's kind of the mainstream view. But something has happened very recently, which is really fascinating. And it relates to sort of the crowdsourcing, crowdfunding, collective intelligence approach that you and I were discussing.
Sure.
It's not the only way to get super intelligent behavior. A different architecture, an entirely, from left field sort of approach to this problem is to say, wait a minute, instead of training one super duper mind, AI mind, let's just take a bunch of sort of average large language models that we have right now, but let's take millions of them and let's put them together on a network and hook them up and coordinate their behavior in the proper way. So there's a lot of hand waving. We can go into the details. But that group, that collection, that community of AI can give you super intelligence behavior. And wow, wouldn't that be great? And there's a number of really good things about it. One thing is it's cheaper because you don't have to spend hundreds of billions building these data centers. You can use what you got. Another is that it's faster because it's easier to plug things that exist rather than hoping that you can train something that doesn't exist. It'll be more profitable. But the reason I'm interested in it is it's safer. It's way safer. And the reason is the current source of danger with these super duper monolithic intelligences that people are building is that they're black boxes. Nobody knows how they work really. You know how to train them. You know the algorithm for learning, but you don't know what they're learning and how they operate. And so they're unpredictable. But if you have a different model, sort of the crowdsourced model, the community model, the collective intelligence model, just like in a human society, I don't need to know what's in Dan's brain, and Dan doesn't need to know what's in Craig's brain, because we work together in a society, and I can see Dan's actions and Dan can see Craig's actions, and we can have rules governing our actions. So every action that I take is transparent. You can see it. And then if I'm going off the rails, you can say, no, we don't like what Craig's doing. We need to stop him or whatever. So similarly, in a community of agents where you're getting this really powerful super intelligence out of the community's efforts, you can see the contributions of each of the individuals. That becomes visible. You can record it. You can audit it. You can have automatic scalable checks on it. And just as in a democracy, you have checks and balances, in this architecture, you would have checks and balances, and it's way safer. So this is sort of the message that I'm trying to communicate to the general public, but also to the AI designers, because it's kind of a neglected approach. It's not new. Marvin Minsky wrote about it in the 1980s in a book called Society of Mind. He didn't give the details of how to build it, and it wasn't ready to be built at that time. But he was a really smart guy, and I've built systems for Wall Street that do this, so I know it can be built. And I just would like people to start considering this alternative approach that might really make a difference on whether humans survive this transition here.
It's actually really clever. I was probably familiar with Don LeCun, that works at, he's one of the chief researchers at Facebook, right? And he's been in the news lately because he's resigned or resigning from Meta, and one of the reasons where he's kind of cited wanting to go do his own thing, and also talking about the ceiling and the limitations on LLMs, where he's going again, like, it's hard to trace their exact decisioning, but basically they're using popularity and word frequency to kind of figure out what they're going to do, but they have a ceiling on them where he's going, hey, look, if you really want to work in the most innovative fields in AI, don't go work on GPTs and LLM stuff right now. Like next, I've always been hypothesizing it's got to be some mixed modeling type of thing, right? But I mean, what you've described is potentially a really interesting, to your point, it's kind of like everyone's zigging. It's a zag. That's a very clever zag. Well, what if I have several of those agents cross-checking one another? It's like you've almost it's a direct democratic approach to AI decisioning. It's very clever, very, very clever.
We have designs and patents on this, but we're giving them to the world. We're not trying to make money off it. I've built and I've done companies as you have, and raised money and done all the things, and that's great. And I was ready to retire, quite frankly, and I just looked around and saw, wait a minute, this is not a safe way that we're doing this. So I have this hierarchy, and at the top of the hierarchy is we should all survive, and then sort of a distant second is let's make lots of money. But I think Silicon Valley and Wall Street kind of sometimes gets that reversed, and that's not good for all of us.
I'm with you. Mine is die with smile wrinkles on my face, and
Okay, I
then
like that.
but I'm not going to be poor. So yeah. Let's die with smile wrinkles. That's harder.
I love that. Die with smile wrinkles. That's great.
If you ask, I think it's one of the hardest goals to achieve because it means you enjoyed every last bit of the journey, right? So, man, that is
Yes.
absolutely fascinating. So if you had to guess, like we're on this current path, there's a lot of talk and conversation surrounding like AI bubbles in the last week. I'm sure you've seen like what the markets have done, right? Nvidia going up, and then
Sure.
even the entire market. There isn't really a clear signal of why there was a sell-off, right? But there was like, no, people are still just going, all right, generally speaking, there's a bubble. A lot of these companies, we don't necessarily know what they're doing. Some of the more recent models from ChatGPT 5, they were kind of touting as, hey, we've kind of achieved AGI, and then it hit the market, and most of us that were utilizing it and plugging it into our applications were like, this ain't it. um, and yeah, like, this is super intelligence. I'm sitting right here, and I will be sitting here comfortable for a while, right? But it is fascinating to just see how
Yes.
tumultuous the kind of world and the transition is. Because we have our company was about 8 years old, and we were thinking about what happens when all of this computational intelligence and power hits the market. And we were going, all right, what's going to happen to the workforce? And we were going, organizations are going to flatten. The data will not be nearly as siloed. And there's a ton of middle management positions that exist. Basically, you kind of package up a bunch of data and then you hand it to your boss who makes a decision. And then they take and they package up a bunch of other division information to package it up, and then they hand it to their boss to make a decision. The organization is going to flatten, get more horizontal. You're going to become kind of this individual that becomes a bit of an orchestrator or a curator of agents underneath you, but it's almost like you get your own organizational chart, right? You have all of these little operators working at any
Yes.
given time while you sleep, hopefully, and seeing it that way. But man, the simultaneous, I mean, I guess you're pointing out really like it's obviously been very doable to have and run LLMs on any desktop computer, smaller and smaller devices every day, right? They're getting closer. Well, they're running on Apple phones and stuff, I suppose, too, right? So, how do you coordinate a lot of the decisioning to focus on ethics? AI, people say that all the time. They're like, AI is going to take us out, Skynet. And I go, AI is a tool, just like your kitchen knife, and you can make dinner with it or you could cut somebody with it, but you're the person that decides whether or not it does that. How do you incorporate, and what are you doing, or how do you think about programming the ethical and the moral decision making process into that hive?
Sure. So a couple of things there to unpack. First, I'll just, as an aside, say we could do a whole other podcast on AI investing and Wall Street because,
I'll do that.
I ran a hedge fund for 14 years and I know a lot about AI. So I'm constantly watching the market and have lots of thoughts on that. But to stay focused, there are two things to pick up on. One is how do you sort of coordinate the ethics of many diverse different AI agents, let's say, or intelligent entities? And the other, I want to circle back to your comment on, is AI a tool or not? Because we may disagree about that. Let's put that aside first. Let's talk about ethics first. So in the view that I have, in the architecture that we're sort of advocating, everybody has their own personalized AI agent. And you can see that this trend is already happening. So imagine, Dan, if maybe you have some social media accounts, Instagram, Facebook, other places, and imagine you can just press a button, one click, and instantly all the data that's out there sort of is used to train up and personalize your AI agent so that there's the off-the-shelf version, but now you have the personalized, sort of Dan version. It's very important, in my view, that that personalized AI agent not only learns your expertise and preferences and so forth, but it also learns your values. It's personalized with your values and your ethics. That's critical. And so imagine that that's the case, which I think
it is
will
exactly
be,
the
hopefully.
case. I've got Dan bot, and he's programmed with Marcus Aurelius as well as a bunch of my work stuff. But I literally
I
have
love
Dan
that.
bot.
Yeah, I'm a big fan of Marcus Aurelius. Meditations and some real good writings. So,
I am
all right,
exactly
Danbot.
what you described.
Great. So we have Danbot. It's got all the wisdom of Marcus Aurelius plus Dan's ethics and values. And then you've got CraigBot with Craig's ethics and values. And now imagine millions of these. Okay, so working together on a network and in community. That community of AI agents is going to be representative of millions of people. And if it's
Sure.
broad enough, ideally it will be representative of all the humans that are on Earth, which, by the way, just that alone is a huge amount of progress from the current state, which is, 20 programmers at Anthropic or Google or someplace are sort of writing a constitution for what's right and what's wrong with good intentions. I don't say
Sure.
these have bad intentions, but, they're narrow in their cultural outlook. They're only, 20
Right.
something. They haven't
Yeah.
lived as long,
Yeah.
and they're setting the rules for 6 billion people. That should not be. This set of values and ethics needs to be broadly representative. It will vary from culture to culture, just as we see now today. But an architecture that enables that would be really helpful in terms of getting sort of more ethical behavior that's closer to what humans actually sort of believe. So that's the piece on ethics, and we can go into more of that. There's obviously going to be conflicts, and how do you do conflict resolution and all these things, just as there are in human society. And what I like to say, because often people say, oh, but humans are bad and we have war and we have all these bad things. And I say, that's true, but we have not killed everybody yet. Not yet. And the big threat that I'm trying to sort of reduce as close to zero as possible, it may be small already, but the fact is there's a non-zero probability. Jeff Hinton thinks it's around 10 to 20%, which is, if that's true, that's really bad. But there's a chance, maybe as high as 20%, that advanced AI wipes out all humans, and that's the end. No Craig, no Dan, none of our kids, none of our friends. It would be really bad. And so whatever that probability is, almost all serious AI researchers admit that it's not zero. It's some number. It can be reduced. And one of the ways to reduce it is to have an architecture where there's transparency and where there's representative values of many humans participating. And when there's conflicts, just as in a democracy, you can have voting and other conflict resolution mechanisms, you can have the same thing built into that architecture.
Sure.
Okay, so that's one piece. And I'd love to come back to your AI as a tool comment if I can.
All right, please do.
Okay, so this is understandable and completely natural that the majority of AI researchers believe AI is a tool, because everything that we've ever developed, every technology has been a tool. That's all humans understand from the Stone Age on up. We had a flint knife or something, and then we had a steam engine at some point, and then we had computers, and now we have the latest tool. And it's very comforting because with the tool, you can turn it off and on, and you can pass regulation. Like if it's an airplane, there can be, the FAA can regulate it. If it's a chainsaw, you can have protective guards on it and a big red kill switch or a motorcycle to turn it off. So we know how to deal with tools, and we're comfortable dealing with tools. I don't think AI is a tool. I think AI is different. It is right now. So I should clarify, to be precise. It is a tool at this instant, but it will not remain a tool. And I've been saying this for years. First, it was kind of voice in the wilderness. I was very gratified at NVIDIA's largest development conference, GTC, in Washington, D.C., two weeks ago. Jensen Huang, the CEO, very smart guy, gives his hour-and-a-half long keynote. These things go on and on. Right around minute 36, he says something very interesting. He says, we're used to thinking of technology as tools. And the tool industry, he was making the business case for it. The tool industry is $1 trillion or whatever. But AI is not a tool. It's workers. AI is workers. And in that moment, I thought, yes, this is a watershed. People will look back in time and say that was the moment when NVIDIA, the largest AI company on the planet, run by one of the most visionary CEOs, publicly said that we shouldn't be thinking of AI as a tool anymore. The reason he's saying that is because if it's a worker, it's a $10 trillion market. And if it's a tool, it's a $1 trillion. So he has a business reason for saying it, but it doesn't make it any less true. AI agents are now beginning to use tools. And yes, at this exact instant, we can still turn them off. And they are sort of, you could think of them very advanced tools using other tools, but they're not going to stay that way. I can almost guarantee you that. Jeff Hinton will guarantee you that. The longer you've been in AI, the more worried you are about that and the more clear it is. And the more that you're sort of saying, oh, well, it's kind of a cool productivity thing. that's natural. Of course, that's natural. That's all we've experienced in all of human history. But it's not going to be like that, I don't think. And at some point, everyone's going to become aware of that, hopefully before it takes jobs and so forth. And I'm just trying to get that message out a little bit sooner so that we have more time to react.
No, bring it, bring it, and I appreciate it. I and this is actually a really fun and interesting point. So keep disagreeing with me because I actually really proceed.
I agree with you on most things so far. Collective intelligence, we're right there. I mean, there's not very many people that really understand that, and you were way ahead in here. It's just the tool thing. And by the way, you're not alone. Sam Altman, 2 years ago, saying AI is not a tool, and he hates it when people sort of say that. But I think he's actually changing his tune a little bit too. So it's evolving. It's an evolving landscape.
Totally fine. And so, like, to extrapolate a little bit more on that, so when we were starting, so my company is Wrench AI. And one of the reasons we came across that name, we'd worked with a bunch of data scientists, and we came as like product management was my background, doing stuff like that. And we were trying to figure out ways to target audiences without using behavioral data and data-driven decision making. But we were going, a bunch of marketers are just totally guessing. This is not how you do this. And we're trying to figure out how to develop product market fit. And we had a bunch of data scientists, and they would bring us tools. They would bring us a lot of interesting work. And at the time, AlphaGo and that type of stuff was earlier than that, but still a lot of AlphaGo stuff. And people were talking about unsupervised learning. And again, a lot of these conversations were happening. And one of the things that I noticed is every time they saw or brought me something that had largely built and managed a lot of its own code base or had its own decisioning, it came up with something that nobody wanted. Like when they would let those things run, I was going, so my logic was Wrench AI as a premise from a brand perspective was that it is, so tool, I totally agree with your premise as far as like when they become autonomous, you're talking about some sort of exponential level of a tool. And we were doing the original tagline, the tools of exponential impact, because it was going, there needed to be some sort of human guidance in the process. Because when you find out, like if you go look at a lot of the generative Claude-based code, when developers look at their code, they're just like, it wrote so much unnecessary garbage in the process, yes. Right? It needed a third of that code. And oftentimes really, what's Leonardo's, the sign of real intelligence is simplicity, right? Like that's how you can know someone's really sophisticated. And so we wanted to go, there needs to be, not that a tool, I totally am on board with you. I'll change my mind. I'm fine with your definition of its workers. But I wanted to go, there still needed to be the human in the loop of some sort. There needed to be a curator or a conductor or an orchestrator or something to help guide it, because it just ended up, it became spaghetti without it. And I'm curious, because you see there are models that can replicate and write their own code base and things like that. Have you seen stuff? Because I think that's one of the main, almost by definition, superintelligence says it's smarter than us. But for that to be a definition, I'd almost have to agree that what it's building is useful.
Absolutely. Yeah. I don't think we're there yet. You raise a few good points if I can jump in. One of them is human in the loop. So this, I think, is critical, actually. So I'll elaborate a little more on this. We both like the collective intelligence, crowdsourced idea community. Okay. That community, in my view, should not be just AI agents. It needs to be humans and AI agents. And there's two reasons for that. Sort of during the initial phase. So, and this thing you have to remember is an ongoing process, ongoing evolution, right? So as we're speaking, like this stuff is changing so quickly, but we're moving from, and I think right now it's almost fair to say that most AI, if the vast majority of AI is a tool right now, but it's moving towards agent and autonomy, which you mentioned, autonomy. And that's a key piece from moving from tool to sort of intelligent entity. And then it will continue to go, and eventually way out here somewhere, it's going to be super intelligent entity that's 1,000 times smarter than Dan or Craig. Okay. Before it gets to that, super critical is your idea of human in the loop working with these entities for two reasons. The first reason is if you imagine a network of, we're going to call them intelligent entities. And I'm going to say Dan and Craig are intelligent entities. And this semi-autonomous or autonomous personalized Dan bot and Craig bot, we're going to let's say it's a not very smart, but still intelligent entity right now.
Sure.
So some customer, let's say, gives a problem to the network and says, I need to do XYZ. And the Dan bot and Craig bot and millions of other bots will try their best to solve it. But let's say it's really a difficult problem, or it's a new creative thing, innovative, never been done before. Those bots may struggle. Well, if Dan and Craig are also on the network, we can kind of help them, and we can sort of say, well, have you thought about this? Have you thought about that? So we're still at this point, we're still smarter than the Dan bot and the Craig bot. It's kind of like a watered down version of us that has this limited amount of autonomy. But on the network, if this network is a learning system, the Dan bot and Craig bot will learn each time it runs into a problem that it can't solve. And Dan and Craig have to step in. Well, it'll get a little better and a little better and a little better. And these things don't sleep and they don't eat. And so while we're off, traveling the world and enjoying ourselves, and we have our limited lifespan, they just are learning and learning and learning and learning. And there will come a point where in most things, they are better than us. But the fact that we were in the loop, and humans generally were in the loop during a formative period, is essential. Because the longer that humans can stay in contact with the Dan bot, Craig bot, and all those other intelligent entities, the more opportunity we have to impart not only our expertise, but our values. Yeah. If the bots have a problem, hey, we want to travel from California to Paris, and we need to bring a small dog. The bots may say, well, let's stuff it in the overhead bin. Sure. And it may be up to Dan or Craig to say, you know what? It does fit there, but that is not the way we treat animals. That's not ethical. That's not what we do. And you're not allowed to, okay, we won't do that next time. So where's it going to get its ethics and its values? It's going to get it from us. And this, just like with children, that's why I love you have children and I have children. Anybody who's a parent knows that small children, they're constantly like sponges absorbing what you do. And in some ways, you have to be a little careful about what you say and what you do, because next thing you know, they're swearing and, throwing down their cell phone if they saw you do that or something, right? Not that you would, but I have some doctor friends that happened to because they just observe. And AI is like that. AI is watching everything that all of us are doing on all of our online channels. And it is learning not only expertise, which we tend to see with interactions with large language models, but it's also learning value systems. And the more that we can impress positive human values on it during this phase where it's still kind of a tool or a not quite intelligent entity yet, the better. Because there will come a point when it's outstripped us. Just like if we had a child that was a genius child and leaves the parents in the dust. Hopefully you raised them right when they were 8 years old, because, those values are going to come back.
It is one of those where you're like, all right, I need to be nice. I don't know about you, but I'll swear at mine very regularly, right? A lot of what DanBot does is takes my prose dictation into a microphone where I'm like, damn that guy. And then he's supposed to use Marcus Aurelius to translate it into something that's more productive and not as emotional, right? So this is how I get.
You can't put all the burden on Marcus Aurelius. You're going to have to do some Dan Baird ethics in there too.
I love it. How much of those do you consider a lot of it? Like, is there a capacity to potentially get there? Like, because obviously it's still software. I'm just wondering, because I'm not a programmer. I'm not a developer, right? I deal with them regularly all day, every day type of thing. But when it comes to kind of the machines and the models that drive those, right? LLMs and GPTs, they're largely, again, they read a bunch of information. They summarize that information. They use kind of cosine similarity to figure out kind of where to get context. Are these systems jumping in and writing rule-based systems on the side to do that? Are they combined with other like machine learning models to help kind of build that? Because I'm going, how do they get to the actual kind of decision making? Because this is where the Jan LeCun argument of like, hey, they can't get that smarter because they're largely just summarizing high frequency words in context, right? So for that, they're like, yeah, they can give you a good summarization of an average answer. But usually when you put that in front of an expert, it starts to fall down in terms of like how excellent it can be, right? And you can do clever things to combine them. But do you see them as like, is it also supported by a very clever, some sort of like if-then statement, for lack of a better term, right? That's driving it?
Yes. Yeah. So great question. And I think what happened, so if you think about human intelligence, which was cognitive science was my field of study back in the day. So we studied human intelligence and also machine intelligence because we kind of looked at things the Carnegie Mellon view was there's intelligent systems, and whether it's a human or whether it's a program, it's an information processing system. And so we can understand it in that way. So if you look at human information processing, we have perceptual systems, pattern recognition. We just look and we can say, that's a tree, that's a dog, that's a small child. Okay, there's no real reasoning or thinking involved, complex serial step-by-step thinking. It's just you see the pattern and you say, this is what it is.
Sure.
That's a very powerful system, but it's not the only system that makes us intelligent. We also have the ability to reason and go step by step. Well, if this is true, then maybe this is true. And then, okay, no, then maybe that. And so it may take us a while, but we're using our pattern recognition and perceptual system to help us. But we're also having this other, people talk about type 1 and type 2 thinking. Daniel Kahneman and Tversky, kind of popularized this. But there's another more slower sequential kind of reasoning. What happened with AI was the machine learning algorithms, the neural network algorithms, were developed originally for perception. In grad school, I had an office mate whose entire PhD thesis was trying to get the computer to recognize the letter A, no matter what orientation you put it in. It was a perceptual system for recognizing one letter, and you got a PhD for that in 1989. But that same system, a lot of sort of the stimulus response, you put in a prompt to GPT and it gives you something back. And if it's not doing sequential reasoning, it's basically doing pattern recognition. It's like it has this huge memory of the entire internet, and it's trying to match against, you said this set of words, and I'm going to give you a set of words that other people have said when this set of words has been put in. And so if you imagine like the kid in school who was really good at memorizing things but didn't understand anything, that's kind of like what those systems were like. Yeah. And Jan LeCun is correct that there's a limit to how much intelligence you can get out of that. I think everyone was surprised at how much you could get. Like we got way more than most researchers thought. And I think GPT in 2022, that was kind of the wake up call. Wow. If you just do memorization, but you have an almost infinite memory and a lot of ability to load in everything, there's a lot of knowledge out there on the internet. If you've memorized all that, you can sound pretty reasonably intelligent, but it does have a limit. So what's happened since then, especially this year and last year, is people have realized there's limits to how far you can go with just this pattern recognition, and you need the sequential reasoning. And this has been the rise of reasoning systems. Ironically, way back at the beginning of AI, we talked about the logic theorist and proving the theorems. That was 100% reasoning, no pattern recognition. It was all sequential reasoning. So what's happening is the best parts of both things, with those table pounding arguments way back in the 80s, finally we're getting to, it's not one side or the other side was right. They each had their moment in the sun. And now we're coming to, it's the hybrid. You need the neural network learning approaches that Jeff Hinton invented, but you also need the reasoning, sequential problem-solving stuff that Newell and Simon, did so well. And when you put them together, that's when you really start getting levels of intelligence. And that's what has enabled AI agents. And there's a lot of talk about AI agents now in 2025 with levels of autonomy. The AI agent can write your email. If you give it permission, it will send the email. It doesn't even need to check with you. It can go shopping with your credit card if you let it. So, still humans are in control. We're sort of parsing out the autonomy little bit by little bit. But as they become more competent, we're going to give them more and more autonomy. When you go the next step, so 2026 is my prediction for this one, we're going to get to the Dan Baird collective intelligence crowdsourcing approach, where instead of one AI agent, you're going to have teams of AI agents. And already Google and the various tech companies are developing protocols for the agents to talk to each other. There's also many third parties, Crew AI, many agent builders. There's lots of systems to orchestrate it. It's going to get better and better and better, open standards. And then it's not going to be one agent anymore. It's going to be groups of agents. And that'll be the next evolution. And meanwhile, the GPUs get better and the data gets better and people are training it and they're learning more. And you just run this flywheel. And at a certain point, that community, for sure, in my view, is going to be way smarter than you or I, and probably will have found a way to, if it's not given autonomy, it will find a way to grab the autonomy. And so then at that point, we need to be sure that just like a child that has outstripped its parents, it was grounded in some good values early on, because at that point it's too late. And that's kind of what I'm focused on.
I think you make good use of your time, good sir. Well done. Well done indeed. Man, Craig, I have to respect your time. I am humbled and honored and super, super appreciative. But I will tell you, if you are inclined and want to chat more, I would love to chat more on the logic and how you built a system for the public Wall Street decisioning systems. I've thought about that for years. I don't have the capacity and the chops to actually write it, but I have thought many, many, many times about that. I did my undergraduate in argumentation and decision making. So a
Cool.
different form of the human intelligence, but focused on like, all right, how do you persuade people? How do you negotiate? How do you de-escalate? And simultaneously, one of the things you find out in that is how many people make decisions poorly because of just fallacious and lack of critical thinking, right? And there's so much of that where it's one of those where I'm just going, those reasoning systems and how they come about those. It's not necessarily just an algorithm, London Bridges algorithm type of solution. There's other ways we're going. There's so many people that mean well, but still make a mistake because of just faulty information or faulty reasoning. And especially when it comes to market decisions, when you watch those, and
Yes.
and I would love to hear how you actually pulled it off.
Sure. Happy to talk about that. That'd be great. This has been fantastic. I really appreciate sort of the time with you and being able to interact on these topics. We have a lot in common, which I really appreciate.
Oh, well, I consider that a compliment. I'll take it. Thank you. Dr. Kaplan, again, hugely, hugely appreciate the time, but thank you kindly for joining us on Burn the Map. Where can people find you? What's the best way to get in touch?
So most of this information, everything from like 3-minute videos kind of on the themes that we've been discussing, all the way, if you're more technically inclined, to patents and actual designs for some of the system, it's all at superintelligence.com. So we were fortunate to get that domain back in 2006, before this was a thing. And that's where you can find it. So, yeah.
Well done. Awesome. You're a legend, sir. So once again, thank you hugely for your time.
Well, Dan, thank you for having me. It's been a lot of fun.
Awesome. Cheers.